Okay, now we go for question number 4. The inlet and outlet impeller diameter of centrifugal pumps are 200 and 400 millimeters respectively. Impeller width at inlet and outlet are 80 millimeters and 8 millimeters respectively. Blade are backward angle with angle of 38 degrees. Pump operates at 1,500 RPM. The flow rate is 15 liters per second. Determine the pressure change in the impeller. Assume there are no energy losses inside the impeller. Okay, so from the question, we have the backward. I think we have a backward here. So we have a 38 degrees. Okay, so and then we could draw the velocity triangle like this one. We could list all the parameter like this one. Okay, because there are no whirl here, I think. Okay, means that in this question, so it should be a statement of there are no velocity of whirl. Okay, let's say we assume that there are no turbulent in inlet. So we could draw the velocity triangle like this one. So and then the question is we need to calculate the pressure changes at across the pump, across the impeller. So means that we need to calculate the P2 minus P1. So and then we make assumption of V1 is equal to 0. And then because we assume that there is no energy losses, so means that just imagine that this is the pump. Okay, this is the inlet, this is the outlet. So we just measure at point 2 here and point 1 here. So means that the head of pump, HP, so it is actually to oiler head because we are focusing on what happened inside this impeller. So that's why we write our Bernoulli equation like this one. So and then oiler head can be written like this one. This is the common equation for oiler head. So we could simplify into this term because the value of V1 is equal to 0. Okay. So and then we could calculate all the values. Say I propose to you, maybe we could start with the simple one. So we have U1 and U2 because it has its own equation, and also the value of VF here. So because it has its own equation. So because in the question there are no statement about the thickness of the blade, so and then we could assume that the value of K here is equal to 100%, or so it is equal to 1.0. Okay, so and then we could get the value of U1, U2, VF1, and VF2. So because there is no statement that velocity of flow is constant, so means that we can take that assumption. So according to the calculation here, the value of V1 is different with VF2. So and then we need to calculate we need to calculate the value of U2 and V2 to get the value of oiler head. So and then to calculate the value of V2, we could look into the velocity triangle at outlet here. So D is V2. This is the angle 38. So you could take here 38 and you could calculate it maybe by using the tangent. Okay, so you use the calculation of tangent here, okay, to get the value of V2. Okay, so and then again, as I mentioned in previous question, in Bernoulli equation here, the value of V1 and V2 is actually the actual. So means that you need to calculate what is the value of V1 here and what is the value of V2 here. Okay, so So in this page, okay, we could calculate the value of V1 is equal 1.6 meter per second. So it's quite straightforward because it is equal to VF1. So however, to calculate the value of V2 here, so we need to use the idea of trigonometry. So we have a Pythagoras theorem, I think. V2 square is equal to VF2 square plus V world 2 square. And V world 2 here can be calculated by using the tangent, by using this idea. So as I mentioned here. So and then the VF2 here is already calculated previously here. So we just use the value. So and then we could get the value of V2. So this is the value of V2, which is 872.5. So this is V2 square. So the value is high, a little bit higher here. It is okay. So and then we have the V1 here, 1.6. So it is okay. We will make it square later on. Okay, and then we need to calculate the value of HE. So according to this equation, you will get it is equal to 94.4 meter. So from the Bernoulli equation, so this is the Bernoulli equation. So we need to substitute the value of V1 square, V2 square, and also the Euler head. So we take its 1.6 square minus with 872 and then we add with 94.4, and then we could get the pressure difference is 491.1 kilopascal. Okay, please remember the question is about the pressure difference. So if the question asks about the pressure head difference, so you need to use the idea of P2 over pi P1 rho G. So this is the pressure head. Okay, please make sure that you know how to differentiate the equation.